minutes and go through this simulation so that you know how to use it to do this batteries and bulbs and circuits in series and parallel labs. So this is what the thing looks like when you first open it up. You've got the home, the intro, which is what you use for the batteries and bulbs, and then the lab, which is what you'll be using for this one, this series and parallel circuits. So if you've already done the batteries and bulbs activity, you know how to set up a basic circuit. So I'm going to go ahead and just start off with a circuit, and for this one I will use a light bulb as my load. And you know, to make a circuit work, we have to have a complete pathway from the negative through the bulb, in one electrode of the bulb, out the other electrode of the bulb, and then back to the positive. And then actually let's go ahead and put a switch in here too. Okay, so there's our basic circuit, and if I click on the switch here and close it, notice the bulb lights up and we have electrons flowing. So let's open the bulb, open the switch, bulb is off, no current is flowing. So here's just a basic circuit with a single load in it. Now, one thing that will be a little bit different in this lab is you're going to be adding multiple loads and you're going to be wanting to make some measurements. Now, the measurements you will want to make will be done with either a voltmeter or an ammeter. Let me show you the voltmeters first. So the voltmeter, if we close the switch and make it work, you just take the electrodes, and these are like wires, and you can connect them at different connection points in here, but you typically connect the negative or the black one to the negative side of something, and a battery provides a voltage rise, a rise in electric potential. So you put the black one on the negative side of it, put the red one on the positive side of it, and so we see that we have a rise in 9 volts. So the battery here is causing an increase in voltage of 9 volts. And if you happen to get the leads connected backwards, your voltmeter will typically still work, but it will just give you a negative reading. So 9 volts. At the load, that electric potential then is being dropped. So the battery kicks these electrons up, gives them more energy, so they've got 9 volts of electric potential. So if we connect the meter across here, it also reads 9 volts, but because we now have a drop. And if we connect, say, across this wire, it reads 0 because there's no difference between one end of the wire and the other. Now, an important idea here is this voltmeter is connected in parallel with this wire. So notice it's not like a geometric parallel, but there's a wire running here, and then there's this pathway right here parallel to it. So voltmeters, when they work, they always connect parallel to the thing that you're trying to measure the voltage across. Ammeters, on the other hand, work differently. Let me pull both of these out. See, can I get rid of that voltmeter? Guess not. Okay, now this ammeter, this one doesn't work like a real ammeter, because this one you just kind of put this on here and it tells you whatever current is flowing through the device. Notice it's the same everywhere. So while that's convenient, that's not the way a real ammeter works, so I'm going to set that one aside for a minute. This one is more like a real ammeter. For a real ammeter, if you connect it, if you try to connect it in parallel like we did that voltmeter, and it doesn't have its own wires on it, you'd have to connect your own. Notice that if we connect it in parallel, one on one side of the light bulb and one on the other side of the light bulb, you get a short circuit. Ammeters will burn up if you connect them in parallel because they have very, very, very low resistance, and so basically what you've done is create a no-load path, and the current all goes through that. So to connect an ammeter and make it work, you can't connect it the same way that you do a voltmeter. An ammeter has to be connected in what we call in series with the load. And what that means is, let's remove one of these wires and we'll put our ammeter there in place of it. Now the electrons flow through the ammeter, then through the bulb, so they're in series. There's only one pathway. And if we want to measure the current with the ammeter, that's how it's got to be connected in. So ammeters always need to connect in series with a load. Voltmeters connect in parallel. Now, having said that, the whole purpose of our activity here is to see how series and parallel circuits work. So if I were to connect another load, say another light bulb, and I want it in series, well, I've got to connect it just like I did my ammeter there a minute ago. So I've got to have this connection up to that one then. Notice the brightness, both bulbs are lit, so we know they're working, but they're not as bright as they were before. And then you can connect 3 bulbs, 4 bulbs, however many you want. You connect them in series and you can see what happens to the voltage, and you can measure the voltage across each of the bulbs and compare it to the voltage at the source. And you can measure the current through the different parts of the circuit. Like in this one, if I wanted to measure the current flowing through this wire right here, we just take that wire out and we put our ammeter in there in that connection instead. And it would show us how much was flowing through that wire. So that's how you make series connections and make a series circuit. Now let me get rid of this for a minute and show you the other way you can do this. The other thing you're going to want to do is make what's called a parallel circuit. And in a parallel circuit, let me set this one up like this. What you do is I want to connect 2 wires to the same connection points that the others were. And let's put this one in here so we have a bend. And then put your bulb like that. So now we've got a parallel circuit. These 2 bulbs are in parallel. Now as you can see, it's kind of awkward to put them in. So sometimes it pays to take a little bit of time and be neat about this. And you can set things up like this. You can actually physically arrange your first circuit. Like that. And now connect this one in parallel. I can just set it here, actually physically arrange it parallel, and just add in my wires to make the connections. And by the way, remember this whole thing is just copper, so if I connect this down here, it is in parallel. But I could also connect it at the other end of the wire, right there. Same thing. And so those are in parallel. So that's how you connect loads in parallel. So in this activity, you're going to be connecting a bunch of loads in series, see the behavior of the circuit, then connect a bunch of loads in parallel, see the behavior in the circuit. You can use your meters to measure the voltage and the current. Again, I showed you how to use the ammeter to connect in series with a load. This one is actually more convenient. It's just that real ammeters don't work this way. But it's nice. I mean, you can just, hold it over whatever wire you want, and you can measure the current. Like there are 1.8 amps flowing through this one, but 0.9 through this one, and 0.9 through this one. That's interesting. I wonder why that worked out that way. So have fun playing with these. See what you can figure out about the series and parallel circuits.